Electrical engineering. Introduction. Electrical engineering is an engineering discipline that deals with the design, application, and study of electrical equipment, devices, and systems using electricity, electronics, and electromagnetism. It involves the generation, transmission, and distribution of electrical power, as well as the design of various devices and systems that use electricity. It emerged as an identifiable occupation in the latter half of the 19th century after the commercialization of the electric telegraph, the telephone, and electrical power generation, distribution, and use. Main fields of electrical engineering include power systems. Designing and maintaining power generation, transmission, and distribution systems, including power grids. Electronics. Designing and developing electronic circuits and devices, including those used in consumer electronics, telecommunications, and medical equipment. Control systems. Developing and maintaining automation and control systems for various applications, including industrial processes. Telecommunications. Designing and developing communication systems, including radio, satellite, and fiber optic networks. Main courses. Electrical circuits. This foundational course introduces basic circuit laws, analysis techniques, and the behavior of various circuit components. Electronics. Focuses on understanding electronic devices like transistors, diodes, and integrated circuits, along with their applications in circuits and systems. Signals and systems. Signal processing deals with the analysis and manipulation of signals. Signals can be either analog, in which case the signal varies continuously according to the information, or digital, in which case the signal varies according to a series of discrete values representing the information. For analog signals, signal processing may involve the amplification and filtering of audio signals for audio equipment or the modulation and demodulation of signals for telecommunications. For digital signals, signal processing may involve the compression, error detection, and error correction of digitally sampled signals. Signal processing is a very mathematically oriented and intensive area forming the core of digital signal processing, and it is rapidly expanding with new applications in every field of electrical engineering such as communications, control, radar, audio engineering, broadcast engineering, power electronics, and biomedical engineering, as many already existing analog systems are replaced with their digital counterparts. Electromagnetism. Explores the principles of electromagnetism, including electric fields, magnetic fields, and their interactions, crucial for understanding various electrical devices and systems. Power systems. Covers the generation, transmission, and distribution of electrical power, including topics like power system protection and smart grids. Control systems. Deals with designing and analyzing systems that automatically regulate and control processes, crucial for robotics, automation, and other applications. Digital systems. Focuses on digital logic circuits, computer architecture, and microprocessor programming, important for digital electronics and computer engineering. Electrical machines. Studies the principles and applications of electrical machines like motors, generators, and transformers. Power electronics. Explores the principles and applications of power electronic devices, including power converters and their use in various applications. What does an electrical engineer do? Power and energy. Power and energy engineering deals with the generation, transmission, and distribution of electricity as well as the design of a range of related devices. These include transformers, electric generators, electric motors, high-voltage engineering, and power electronics. In many regions of the world, governments maintain an electrical network called a power grid that connects a variety of generators together with users of their energy. Users purchase electrical energy from the grid, avoiding the costly exercise of having to generate their own. Power engineers may work on the design and maintenance of the power grid as well as the power systems that connect to it. Such systems are called on-grid power systems and may supply the grid with additional power, draw power from the grid, or do both. Power engineers may also work on systems that do not connect to the grid, called off-grid power systems, which in some cases are preferable to on-grid systems. Renewable energy focuses on the principles and technologies behind renewable energy systems, such as solar power and wind power. Control engineering. Control engineering focuses on the modeling of a diverse range of dynamic systems and the design of controllers that will cause these systems to behave in the desired manner. To implement such controllers, control engineers may use electronic circuits, digital signal processors, microcontrollers, and programmable logic controllers, PLCs. Control engineering has a wide range of applications from the flight and propulsion systems of commercial airliners to the cruise control present in many modern automobiles. It also plays an important role in industrial automation. Control engineers also work in robotics to design autonomous systems using control algorithms which interpret sensory feedback to control actuators that move robots, such as autonomous vehicles, autonomous drones, and others used in a variety of industries. An example for control application. In an automobile with cruise control, the vehicle's speed is continuously monitored and fed back to the system, which adjusts the motor's power output accordingly. Where there is regular feedback, control theory can be used to determine how the system responds to such feedback. Instrumentation. Instrumentation engineering deals with the design of devices to measure physical quantities such as pressure, flow, and temperature. The design of such instruments requires a good understanding of physics that often extends beyond electromagnetic theory. For example, flight instruments measure variables such as wind speed and altitude to enable pilots the control of aircraft analytically. Similarly, thermocouples use the Peltier-Seebeck effect to measure the temperature difference between 2 points. Often instrumentation is not used by itself, but instead as the sensors of larger electrical systems. For example, a thermocouple might be used to help ensure a furnace's temperature remains constant. For this reason, instrumentation engineering is often viewed as the counterpart of control. Telecommunications. Telecommunications engineering focuses on the transmission of information across a communication channel such as a coax cable, optical fiber, or free space. Transmissions across free space require information to be encoded in a carrier signal to shift the information to a carrier frequency suitable for transmission. This is known as modulation. Popular analog modulation techniques include amplitude modulation and frequency modulation. The choice of modulation affects the cost and performance of a system, and these two factors must be balanced carefully by the engineer. Once the transmission characteristics of a system are determined, telecommunication engineers design the transmitters and receivers needed for such systems. These two are sometimes combined to form a two-way communication device known as a transceiver. Electronics. Electronic engineering involves the design and testing of electronic circuits that use the properties of components such as resistors, capacitors, inductors, diodes, and transistors to achieve a particular functionality. The tuned circuit, which allows the user of a radio to filter out all but a single station, is just one example of such a circuit. Another example to research is a pneumatic signal conditioner. Prior to the Second World War, the subject was commonly known as radio engineering and basically was restricted to aspects of communications and radar, commercial radio, and early television. Later, in post-war years, as consumer devices began to be developed, the field grew to include modern television, audio systems, computers, and microprocessors. In the mid to late 1950s, the term radio engineering gradually gave way to the name electronic engineering. Microelectronics engineering deals with the design and microfabrication of very small electronic circuit components for use in an integrated circuit or sometimes for use on their own as a general electronic component. Thanks for watching. For more videos, please like and subscribe.